To all the listeners, good afternoon, good morning, good night, wherever you are located. Since I'm working for a research center that is owned by a trade association, it is our mission to regularly being interested in checking whether and how research and development results can be applied by the industry. And so we do here in the Circles of Life project. So my colleagues and I are particularly addressing this question with respect to the CEPI concept. So the means to this end is to perform case studies and to develop a best practice guide. So what does it mean? During the next minutes, I'm going to start by explaining what is the scope of these case studies and what is the approach we are going to apply. And thirdly, as an example, we will have the opportunity to dive a little bit deeper into one of the case studies. That is the one which is coordinated by the Damen Group. And finally, I will conclude by explaining how we deal with best practice examples, which we identified during the Circles of Life project. So let's start. You have seen this picture before. With the scope of the case studies. So the blue boxes here are representing all the life cycle phases of a ship except the ship operation. Please have a look at the highlighted parts now. Those are the 3 life cycle phases which we selected for the case studies. And the green boxes which appear now, they are representing the 4 case studies which we are performing. You can also read the addressed processes and the shipyards which are leading each of the case study. So in each case study, we concentrate on processes which are prone for high emissions. So we used our educated guess before taking any measurements. We had a certain idea of which processes are usually those which come with high emissions and where do we see potential for improving and where we can showcase how the CEPI concept works. Then let's talk about the approach. So the first of 6 steps is to understand better how the process which we selected for the case study actually works. So the shipyards and the involved suppliers are breaking down the processes into sub-processes. And while doing this, they answer questions such as what kind of emissions are there, when do they occur, and where. And finally, it is also determined whether data about the as-is emissions are already available, so whether we can make use of historical data, or whether and how the data can be obtained by measurements. The second step is to get a better understanding about options, which means technologies which can help reducing the emissions. So the owners of the processes and the owners of suitable solutions come together and analyze the mode of action. So how would innovative technologies with less emissions help reducing the emissions? How effective could they be? And do we expect any potential interactions with other processes when implement new technologies? So as an example, you can take laser welding. So if you introduce laser welding as an alternative technology for joining, you do not only need to look at the emissions which occur during the joining process itself, but also at side effects. So laser welding usually comes with higher accuracy. Therefore, you need less rework after the joining. Therefore, you have less rework or less emissions during rework. This is also contributing to the overall emission balance. Then, third step, choosing the assessment method. So different emission estimation techniques will be selected based on the specific processes and emissions. Methods such as direct measurement, mass balance, engineering calculations, and acknowledged emission factors will be applied. As a fourth step, the assessment will be performed. So we will use the chosen assessment methods, will obtain emission figures as well for the as-is situation, but also for the scenario for the situation after introducing improved technologies. And the results will be input values for calculating the CEPI values using the tools, the software tools provided by CirclesOfLife. And the last two steps are related to collecting feedback and processing the results of the exercise. So first, collecting feedback from those who performed the case study will be used within the project consortium in order to understand the usability of the CEPI concept and the related tools, and to apply measures in order to further improve the solutions. And this, the last step is to work on the inventory and best practice guide. So the know-how on low emission shipyard processes will be collected from the case studies performers and will be compiled into an inventory and best practice guide. So now let's look into the case study, which is led by the Dahmen Group. And as already indicated, this case study is dealing with repair and maintenance. So in step number 1, as you remember, we call it understanding the as-is process. We make use of a commonly agreed standard for process modeling, the so-called generic shipyard model which Martin already mentioned. So on this picture, we see an overview of the entire generic shipyard model. And on 3 different hierarchy levels, all the possible processes in a ship's life cycle are included. However, in our case study, we are only interested in maintenance and repair processes. So we can concentrate on those processes under this magnifying glass. So the individual shipyards, for instance, Dahmen, when doing this case study, can utilize the generic shipyard model and select those processes which are applicable to them. And then we have to be aware that this is still a generic process. It does not reflect all the specific ways the process has been implemented at Dahmen. This will needs to be considered in the next step when going to the next level. And because if we want to assess a specific shipyard's eco footprint, we need to consider how the process is implemented. And this involves modeling of the sub-processes and allocating the technologies used in those sub-processes. And this happens on this next level, which is represented here. Most probably you cannot read it, but let's have a quick look. What you see is a model of a painting process. And at this level, we are doing business process modeling in order to document the various information, for instance, sequence of sub-processes, the regulations which are applicable when doing the process, and the technologies applied. On the bottom, you see a number of processes in parallel, or sub-processes in parallel. Those are processes which can be used alternatively. So you have different options how you can perform the processes by using different technologies. I will come back to this on one of the next slides. On this level of modeling the sub-processes, we also define the data points where we allocate the emissions associated with the processes. These emission values are needed for later processing them in order to calculate the overall CEPI value of the shipyard. And now I will continue coming back to the technologies and comparing them against each others. So, oops, that was too quick. So the second and third step is what we also call technology scouting. So you might remember that surface treatment was identified as an emission hotspot in repair and maintenance. And among others, the technologies which are being compared in terms of emissions, working conditions, versatility, and technical limitations. So those are the aspects which can be used. So the upper picture shows you some examples of conventional technologies which are currently used at the shipyard, which is investigated in the case study. So you can imagine that these technologies are not totally free of emissions. The working conditions are safe. However, the jobs are not the most attractive ones, if you can say so. This leaves room for improvement. Below, you can now see some of the results we obtained from the technology scouting process. So technologies we identified, or Damen has identified as candidates for improving the situation. So they are both based on robot technology, and they both offer advantages in terms of lower emissions. So the robot on the right is equipped with water jet technology and a closed water circuit, which involves filtering and cleaning of the water. And in addition, thanks to an interchangeable head, the equipment is also versatile, which allows to not only perform one of the sub-processes, but applying the technology for, in this case, paint removal and application of paint. And the robot on the left does not require docking of the ship, which can also be an advantage. Even more advantages for both of the two robots can be seen on the economic side. Working with them is quite efficient. However, there are also some disadvantages which have been identified. So these two robots cannot be used for any kind of surfaces in terms of how the surface is shaped, meaning they are best suitable for even surfaces, but not for curved ones. So having said that, I will talk about steps 4 and 5. Those are currently still work in progress at the participating project partners. So after having done the technology scouting, you need to think how the results will translate into the CP, or how they will be translated into the CP. So on the left-hand side of this picture, you see the concept of Circles of Life, providing a platform of Circles of Life tools, which we are going to provide. All these tools, for instance, the generic shipyard model, are generic, so they do not representing specific shipyards. The customization takes place in the second column, so there we use the tools in order to represent individual entities. And for specific shipyards, a digital model is created based on the generic shipyard model. And then, last column, during the course of the case studies, we are collecting data which allow us to compare the as-is processes where the current technologies are applied with the situation after a potential introduction of alternative technologies, so the to-be scenario, let's say. And these data are obtained by different means, like performing measurement campaigns or taking into account historic data. And all this data is entered into the Circles of Life platform for further aggregation, processing, and calculation of the CP values. And finally, once we have these calculated CP values, they can be used or they can be attributed to the shipyards as well through the Ship Lifecycle Passport, SLP. The score will also be assigned to the ships built, repaired, or scrapped at the shipyards. So those were, oh no, it's not the end. I forgot the sixth step. How will the outcomes be represented? So this leads us to the sixth step, which we call inventory and best practice guide. So the accumulated knowledge will end up in a best practice guide. which we are compiling during the project. One part of the best practice guide might be a book, like the AI representation given here. And this book can give advice on how to implement the CirclesOfLife solution platform on a shipyard. But we want to provide more than that. So other parts of the best practice guide will come maybe with different types of media, probably as a software that allows decision makers to compare technologies using specific scorecards, which we plan to offer. So not only environmental, but also economic, technical, and social aspects can be assessed before taking action. I want to underline that while the CEPI method, which is the calculation of the environmental performance, will be standardized, on the other hand, the users will be free how to assess the other aspects and to define their own weighting factors before taking a decision. So all this helps searching for solutions which in the best case provide a what we call win-win-win-win situation, meaning excellent performance in all criteria, as mentioned, environmental, economic, technical, and social aspects.